Well guys, it's that time of the year. The magnolia is in full bloom. So yeah, always nice. Until, I don't know, about 2 years ago, I had this like a lawn, you know, with grass nicely trimmed and everything. But then my brother was telling me about, you know, the plight of the bees and stuff, and how with all these monocultures everywhere, there's less and less for them. So I decided to just let this grow and see what would happen. And well, it's tons and tons of flowers of all sorts, and consequent increase in the insect life and the bird life. Yeah, times like this you think life could be worse. Something else that's really interesting is how the tuning condenser is isolated from the rest of the chassis. Normally, as I think most of us have seen, they tend to be mounted on rubber grommets. This thing is an altogether more elaborate affair, because you have two spring steel rods fixed to the chassis here, and then fixed to the tuning condenser over there, so that it floats. Then on the back, at the back there's a spring underneath here. Then at the back also there is a little soft pad here that sort of limits the travel up and down, side to side. And last but not least, there is what is like a shipping screw, like you get on a turntable. So when you screw this all the way in, you basically lock this part here, which is the tuning condenser, to this part here, which is the chassis. So now it doesn't move around anymore. How's that for engineering? I thought it was pretty damn clever. And when you tighten that spring up, it pulls the whole thing back. And if we go back to the front here, you'll see there's like a little pyramid, half pyramid shape here on the tuning condenser, and it's got little pads here on the chassis, so when you pull it back, it rests against these like felt pads. How's that for engineering? Pretty impressive, huh? I like it. Okay, next I think is take this off the sub-assembly board here. And then maybe do the same with the transformer. Clean all the board up and the transformer as best I can. Then put the transformer back and start rewiring the whole start from the AC inlet and go from there. So there we go, this is the underside of the RF section. Again, I'd say this would be not too onerous were it not for the fact that all these rubber wires are just about ready to turn into dust, green dust everywhere. I think we can safely assume this capacitor here has had it. So we'll get him out of there, see if we can find out what value it is and replace it. Well guys, rewiring this transformer has taken me pretty much most of the day. The way I did it was basically remove one end of a wire, tag the new one on, and then follow it to the other end, take it off and put the, you know, basically replace it wire by wire one at a time. Some of the short runs of wire that interconnect between these selector pins, I I just lifted one end and put some component leg sleeving on it rather than replace it. Yeah, no fuses anywhere, so I'll have to put a line fuse or something, because these guys go off to the dual pull on off, mains on off switch on the side of the cab. I have a feeling I'm going to rig up a temporary switch for that, for testing purposes. Yeah, the huge cap that was here between one of the plates and ground, impossible to tell what value it is, but my best bet from looking at the diagram is 0.022, because it's if it's the one I think it is in the diagram, it's 22,000 puff marked in the component list. But as you can see, this guy has definitely given up the ghost. On my capacitance meter, it measures about 100 nanofarad. That's that bit done. I hope, as I say, I didn't make any mistakes along the way. So when it comes time to fire this up, we'll put it on the variac and we'll do it very slowly. Okay, that's that piece of it. I guess the next sensible bit would be the rest of the power supply and audio amp section. I'm checking one of the smoothing caps out of the power supply. According to the diagram, it's 45 microfarads. The markings on it here, the nearest I can see is a 50, but it's basically 450, 500 volts. When I give it about 350 volts, there's no leakage, and there's like 0.6 of a milliamp, and you can see it's dropping down, so I'm sure that's fine. Now the next level up on my tester is about 440 volts, and if I give it 440 volts and touch, you see we have leakage. Now if I look, it's 3 milliamps and dropping. I mean, it was like 3.3 when I first did this, and it's slowly going down, so I have a feeling it probably will form. And the neon is not lit up as much now as it was when I first did it, so I have a feeling this thing will reform, and since we're right up at the top end of its tolerance, I'd say we're okay. I think I'm going to run with this cap and be gentle with it. It's got some what look like spanner marks along here, so it looks like somebody might have had this out before. Not sure, because for me it just screwed out to the Bakelite base dead easy, no problem at all. Anyway, so I will check the other electrolytic as well to be sure, but it's looking good so far. This is the second smoothing cap out of the power supply. Even though the circuit diagram has the two caps as slightly different values, one is 45 and one is 32 microfarads, these are both identical that I'm taking out of the set, so I don't think it's hypercritical. And this one tests pretty much good like the other one, both in terms of capacitance reading and leakage test, so I'm going to go with these. One of the hassles is basically getting all the wires off the cap and trying to get them back on again. So what I'm doing here is when the cap is out, attaching all the wires that I can to it when it's out, and then I screw this in, and then I feed the wires off to where they have to go to, and then there's one other component, the resistor, which has to solder, which is already in there, which I can't really get at until the thing is in. So that's the plan, to try and ease the pain a little bit of getting at this at this thing in such a confined space. Well, this is going to take a long time, and I get the feeling I can take this in small doses only. Anyway, so here's what we got so far. So here's one smoothing cap in the power supply. Here's the other one. This little guy here, it looks like a coil, is in fact a wire rod resistor across. So, and all the wires that were going to those are rerun to their destination. And then I've sort of started at this end and working my way up. So of course, as often with these sets, I don't have exactly the same value that I took out. So get as close as possible. Checked all these resistors, they all look to be fine. There was a huge cap here which I took out. Fortunately, it had its value on it, so it's a 0.18. And so I put in a 0.22 because it's the closest I had. And I found out which one it is by looking up on the power supply and the list of components, and luckily there's only one cap with that value, so then I can go find it in the circuit diagram, etc., etc. So yep, we're getting there slowly, and what I'm trying to do as well is start furthest away from me and then work my way up through the multiple layers, so that hopefully once I get a piece of wiring done, I don't have to mess with it too much again. Not going to be always possible, but yes, we'll get there. So as I say, there's probably not much more to show you guys until I get this done, and I might probably be able to then test the mains transformer, hook it up to this, and see if we have an audio amp that works. More to come.